Hello guys, and welcome to this video today in our channel. In this video guys, we shall be looking at the integral of tangent of x versus the integral of tan inverse of x dx. Keep in mind guys that these two functions are inverses, okay? Like the inverse of tan x is tan inverse of x. So guys, stay tuned and watch the video from start to finish guys, because along the video you are going to, because after watching the video from start to finish guys, your knowledge in integrals are going to change for good. Okay, they will change for good. So guys, please, just for a quick reminder, if you're new to our channel, just press the subscribe button right now and follow and press the bell icon so that you are going to be notified each time we have videos. Keep in mind guys that we upload videos in this our channel every day of the week. Okay, every day guys, we have new videos on interesting topics in biology, chemistry, physics, mathematics, that's further mathematics, computer science, and the rest guys. So guys, you can't afford to miss. Okay, you can't afford to miss. So just press the subscribe button so that you are going to get notified. Thank you very much guys. Let's dive straight into it. So guys, assume the fact that you're in an exam and this integral have been presented to you. So guys, tell me, which of them are you going to start solving? Which of them will you start? Yeah, done. So guys, according to me, I don't know for you, but we all know in the general case scenario, right, the integral of tangent of x is more easy than the integral of tan inverse of x, right? So guys, let's start with this. Okay, let's start with this. So now in the first case guys, we are going to look at tangent of x to be the same like sine x over cosine of x. Good. By so doing now guys, we can let our u sub, we are going to let u to be the bottom, we are going to let u to be cos x. Guys, some of you will be asking me that why didn't I let my u to be sine x, even though if we let u to be sine x, du gives us what? Cos x, which is what we have at the bottom, but we are going to have du, we are going to have our du to be cos x, which is what we have at the bottom guys, but we don't want our du to be at the bottom. We don't want du to be at the bottom. We want du to always be in the numerator. So that's why we won't let our u to rather be the denominator, rather be the numerator guys. So in this case now, if we let our u to be the denominator, which is cos x, differentiating that guys gives us negative sine x dx. We have sine x at the top, right? So the negative is just a constant, it doesn't really matter. So guys, we can now take this integral now from the x world to the u world. So guys, in this case now, we are going to make dx the subject. By making so, we are going to divide all by negative sine x. We are going to have our dx to be negative du other than sine x. Good. So now guys, this our original integral now turns out to be, we have the integral of, we have sine x. What is our cos x guys? It is what? Our u. Then guys, dx, which is the u we have here. Then guys, dx, what's our dx according to this guys? Well, negative du other than sine x. So guys, this du here is a mistake. Okay, this is not meant to be here. Okay, just this one is meant to be a du here, was not meant to be here. So guys, erase it. All right, good. So now if we simplify now guys, we'll see that sine x and sine x, they can cancel, right? Good. And we can put the negative sign in front of the integral. So we're now going to have negative of the integral of 1 over u du. Great. So guys, like I was saying, this du was not meant to be here. We are going to have this. And guys, what's the integral of 1 over u du? That's great, you got it right. So guys, we have this word to be the natural log of u, but since we have the negative here, the negative follows. We have the natural log of the absolute value guys of u. Why absolute values and not just brackets? Because we want to take care that this our u should never be less than 0, because we know that the natural logarithm is not defined when u is less than or equal to 0. So our aim now is to take care of it so that it should never be less than or equal to 0. Good. So now guys, the normal 0, as we are done with the integration, we end up with our word plus c. But guys, keep in mind that we're in the u world, right? We have to glyph from the u world back to the x world. But what is our u guys? It is cos x. Good. So now guys, everything now translates into the negative natural logarithm of absolute value of cosine of x plus c. But guys, we can modify this guy a little bit. We can bring a negative sign inside of the logarithm, and we are now going to have the natural log of 1 over cosine of x, which is the same like secant of x. So we have the natural log of sec x plus c. Great. So guys, this is what we have as our answer. So we can therefore conclude, guys, that the integral of tan x is the same like the natural log of this. Good. So we can therefore conclude the integral of tan x is the same like this. So guys, I'm sure it was pretty very easy, right? It was pretty very easy. So guys, without wasting much of your time, let's dive straight into the next. Let's look at this guy. Alright, good. So now guys, let's look at the integral of tan inverse of x. We are going to use the DI method, that's the integrations by part method. Okay guys, because we cannot express tangent of x as in a similar case like how we did here. So guys, in this case we are going to use integrations by part. Why? Because we can differentiate tan inverse of x, right, and we can integrate dx or 1 times dx. So we are going to use integration by part, and a summary of integrations by part, guys, is called the DI method. That's why I have a D here. Then I also need an I. Good. And I have a D, I need an I, and this is the I, guys. Then the signs starts from positive to negative, and in that same pattern, guys. So the first sign is going to be positive, and the next sign, guys, becomes negative. Now the most difficult part now, guys, is to choose which of these guys will you differentiate, which one will you integrate. So guys, if we choose to integrate tan inverse of x here, then differentiate 1 dx, we see that it is the original function, guys. So in this case now we are instead going to choose tan inverse of x to differentiate that, then integrate 1 dx. Good. So guys, please, just a quick reminder, if you've not subscribed at this point in time, guys, just hurriedly hit the subscribe button right now, because in this channel you're going to be seeing interesting, great contents that are going to help you a lot, guys. A lot involves a Laplace transform and the rest, the whole of calculus, differentiation, everything in chemistry, in physics, everything, guys. It is going to be present in this channel. So guys, you can just support us by subscribing to the channel and liking this video, guys, because it's very important to us. It actually tells us that you found contents like this useful, guys. Thank you for liking the video and subscribe, most importantly, guys. Alright guys, so like I said, we are going to differentiate tan inverse of x, and we are going to integrate 1 dx. Good. So now guys, differentiating tan inverse of x simply gives us what? Great, guys. I have a video on this guy. I have a video on how to differentiate tan inverse of x, so I'll put the link to that video in the description for your convenience, guys. So just check this video description, and you're going to see a video that is going to lead you on how to differentiate tan inverse of x. Good. But I'll just tell you guys the answer you are supposed to get. You're going to have 1 over 1 plus x squared. Good. Then guys, integrating 1 in the x world simply gives us x. Good. The variable, it simply gives us the variable x. Great. So now guys, the integral of all of this now, of the tan inverse of x, guys, the integral of that now simply gives us now guys, we are going to multiply these two diagonals. Okay, we multiply the two diagonals. That is going to give us x times the tan inverse of x. Then now guys, we also multiply by these diagonals here. We multiply by these two guys and still put that inside of an integral, guys. We still put it inside of the integral, and we'll keep a negative sign outside. So we are going to have negative of the integral of x times 1 is x over 1 plus x squared dx. Good. So now guys, this is simply going to give us, we are going to multiply outside by 1/2 and here by 2. Why are we doing so, guys? You see that the 2 and the 1/2 can cancel, right, and it gives us the original problem. Guys, why are we doing so? Why are we multiplying by 2 and dividing by 2? Okay guys, let's take a look at here. Let's have a look. So guys, we are doing so because if we differentiate 1 plus x squared, it simply gives us what? 2x. But we don't have the 2 here. That's why we multiply by 2 and we divided by 2, such that the 2 and the 2 they can cancel. Nothing is changed. So guys, if we let our u to be 1 plus x squared, like I said, and we differentiate, we are going to have du to be what? 2x dx squared. And guys, we can therefore bring this integral now from the x world to the u world. If we look at just the integral of 2x over 1 plus u square 1 plus x squared. If we replace our 1 plus x squared with our u, then 2x dx by our du, we are simply going to have the integral 1/2 is there. We are keeping this negative sign aside. We are going to have 1/2 times the integral of just 1 over 1 plus x squared is our u. We have u here, then 2x dx our du. Good. So now guys, and the integral of 1 over u du, guys, we saw here to be what? Natural log of u, but what is our u? 1 plus x squared. But guys, keep in mind that 1 plus x squared is what? Always greater than 0, right? It is always greater than 0, so it can never be 0. So we don't need the absolute value sign. We don't need absolute values. Yeah, we don't need it. All we need is simple brackets. So guys, everything now simplifies into, we have the integral of all of this now becomes x tan inverse of x as we have it here, minus now 1/2 times the natural log of, we have 1 plus x squared. Oops, guys, I forgot the plus c, but you just add it, okay? We must end with our plus c. You just add it. So guys, keep in mind that the integral of the tan inverse of x dx is not the same like the integral of sine inverse of x over cos inverse of x, okay? These two guys are not the same. This is most mistake that students always do, and they end up not getting the mark, okay? These two guys are not the same. So guys, please don't forget to subscribe to the channel and like the video. That does motivate us to produce more and more content for you. Thank you very much. So guys, the integral of tan inverse of x dx, this is the answer here, then the plus c, this is the answer here. But guys, the integral of sine inverse of x over cos inverse of x, guys, it is a sad face, okay? It is a sad face. Why? Because it is not elementary, okay? We cannot get an elementary value for this guy unless we use special functions, and we have to be so discreet about it, okay? Unless we use special functions. So thank you very much guys for watching the video, and I hope you enjoyed the video, guys. Just leave it in the comment section if you enjoyed the video. Thank you very much, and don't forget to subscribe to the channel and like the video. That is going to help out a lot. Coming up soon, guys, the next question is coming up soon. Thank you very much for watching, and have a great day.